The Hobart Kugelblitz scale-safe law, energy density as the systemic failsafe and boundary vector of sentient observation. Part 1. The concept of active containment. In classical physics, cosmic limits are treated as passive, static parameters, arbitrary values painted onto the background of an empty vacuum. The velocity of light is routinely described as a speed trap with no clear engine of enforcement, while the Planck length is framed as an inconvenient technical floor where current microscopes simply run out of resolution. This paper establishes a counter-thesis. These boundaries are not passive signposts, but the structural grid lines of an active, self-regulating topology. The universe does not police its parameters with arbitrary edicts, it enforces them through dynamic, mathematical resistance. We term this transactional enforcement mechanism the Hobart Kugelblitz scale-safe law. This law states that the act of pushing an object through space or concentrating diagnostic energy to extract information from a local frame triggers an exponential counterforce. The universe weapon eases the interloper's own kinetic or investigative energy, converting it directly into local mass energy density until spacetime folds over the event, sealing the boundary behind a localized event horizon. The system is entirely self-contained. The entity attempting to breach the parameter provides the raw material for its own confinement. Part 2. The privileged vantage point, sentient bandwidth of the macroscale. To understand why a toll exists, we must first analyze the unique, untaxed sanctuary occupied by human sentience. The biological architecture of Homo sapiens is positioned within a remarkably wide, highly resolved middle tier of the cosmic ladder. We exist in an untaxed zone where our sensory apparatus can navigate massive dimensional disparities without ever drawing the regulatory notice of quantum mechanics or relativity. Consider the mechanical scale of human perception. A single Demodex mite inhabiting a human eyebrow hair follicle measures approximately 3 × 10⁻⁻⁴ meters. An individual atom sits at roughly 10⁻⁻10 meters. The mite is 3 million times larger than the atomic foundation beneath it, yet a human being is only 5,000 times larger than the mite. Our biological sensory net is so finely calibrated that our neurological matrix can perceive the minute, localized mechanical friction of a microscopic arachnid moving on a hair follicle. We are an astronomical collective of billions of trillions of subatomic particles, yet we operate with a sensory bandwidth clean enough to register disturbances at a scale thousands of times smaller than ourselves without injecting disruptive energy into the system. The universe permits us free observation across this vast macro bandwidth because our native biological processes do not threaten the stability of the cosmic grid. Part 3. The biological focal barrier and the retina grid. The limits of this free biological sanctuary are explicitly demarcated by our own optical hardware. Human vision possesses a hard floor known as the near point of accommodation. Through deliberate physiological manipulation, the human eye can push its lens mechanics to their absolute structural limit. By crossing the eyes and bringing a target to a distance of approximately 4 inches, the ciliary muscles compress the biological lens to its maximum thickness. This action refracts light at the steepest possible angle, allowing a human observer to resolve the ultra-fine, sub-pixel crystal lattice of an advanced display, such as a modern smartphone screen. Yet, this biological exploit immediately collides with a hard hardware floor. We are limited not just by the flexibility of the lens tissue, but by the pixelation of the retina itself. The rods and cones on the retinal surface are spaced at discrete intervals. Once a perceived object shrinks below the physical gap between adjacent photoreceptors, the biological hardware can no longer resolve separate points. The image blurs into a uniform field. This retinal pixelation serves as a safe biological guardrail. It prevents the naked eye from ever focusing hard enough to see the atomic world, keeping human observation firmly within the energetic zone where information can be gathered without a physical cost. Part 4. The invention of strategic lenses and extensional devices. Because human sentience possesses an inherent drive for systemic optimization and strategic leverage, it refused to accept the boundaries of the retinal grid. To look closer and harder at the structure of matter, humanity began creating artificial extensions of its biological senses. This marked the transition from passive observation to active intervention. We engineered curved glass to bend light beyond biological limits, developed electron beams to replace the wide wavelengths of visible photons, and constructed scanning probes to descend into the microscopic abyss. In doing so, we stepped completely out of the untaxed biological sanctuary. To bypass the blurred pixels of our own retinas, our machinery had to begin interacting directly with the fundamental components of matter. We were no longer merely catching the ambient, low-energy light reflecting naturally off an object. We were forcing our way down to the pixelated floorboards of the cosmos. This technological leap shifted the relationship between the observer and the observed from a one-way street into a high-stakes transaction. Part 5. The operational reality of the double-slit interruption. The moment our devices began probing the subatomic world, popular science lost its footing, substituting physical mechanics with mystical jargon. The double-slit experiment is the primary casualty of this narrative failure. Pop culture documentaries routinely claim that a particle changes its behavior based on conscious observation, implying a supernatural link between mind and matter. Our framework strips away this mysticism to expose a cold operational reality. In physics, observation is not a passive glance, it is a physical collision. When a particle travels through the double-slit apparatus unmonitored, it exists as a spread-out wave of probabilities, passing through both slits simultaneously to create an interference pattern. To determine which slit the particle actually chose, we must place a detector at the gap. But a detector cannot extract information out of a vacuum. It must strike the traveling particle with a diagnostic probe, typically a photon of light. The resulting change in the particle's behavior is not a response to a conscious mind, it is the mechanical consequence of quantum decoherence. The high-energy diagnostic photon smacks the delicate wave state like a billiard ball, transferring kinetic energy and physically forcing the wave to collapse into a single localized point. The experiment is not flawed, but the vocabulary is. It should be termed the interruption experiment. The universe enforces a clear rule. You cannot extract a secret without physically striking the target. Part 6. The energy tax on information extraction. The mechanical collapse observed in the double-slit experiment is the first warning sign of a universal tariff system. Information is not free. It is inextricably bound to thermodynamics. To extract a highly precise data point regarding the position or state of a subatomic particle, an observer must utilize a diagnostic probe with a correspondingly short wavelength. Basic wave mechanics dictate that shorter wavelengths require higher frequencies, and higher frequencies carry higher energy. Therefore, as you attempt to see finer details, your diagnostic tools must carry increasingly violent loads of energy. When you probe an atom, you are no longer a detached bystander. You are injecting massive amounts of energy into an infinitesimally small local frame. The universe tracks this transaction with absolute precision. The more certain you demand your data to be, the harder you must hit the system, and the more thoroughly you alter or destroy the very state you were trying to measure. This is the energy tax on information extraction, the foundational principle that scales directly into the Hobart Kugelblitz scale-safe law. Part 7. The Lorentz factor and the relativistic velocity boundary. To map the full scope of this containment topology, we must examine how the universe polices its upper macroscopic boundary. This is the velocity limit, conventionally known as the speed of light, c. Just as pop science misinterprets the subatomic world as a place of magic, it views the speed of light as an arbitrary cosmological speed limit that could be bypassed if we simply engineered a powerful enough engine. The actual mechanics are governed by the relativistic mass equation, where m_0 represents the rest mass of the object, v is its current velocity, and c is the speed of light. As a massive object is accelerated, its velocity versus approaches c. This causes the value under the square root to approach 0, which drives the total dynamic mass m toward infinity. The universe does not block the object with a physical wall. It alters the object's intrinsic properties. The faster you try to push the entity, the more massive it becomes. Consequently, the next increment of acceleration requires even more energy. Your own effort is actively converted into the very inertia that stops your progress. Part 8. The Kugelblitz mechanism, radiation-induced collapse. Because mass and energy are equivalent expressions of the same underlying metric, E equals mc squared, the astronomical amount of energy required to push an object close to the speed of light cannot remain localized without consequences. If an engineer attempts to force a physical craft past the velocity boundary by continuously pumping brute force kinetic energy or radiation into its propulsion frame, the local energy density spikes toward infinity. In general relativity, gravity does not care whether mass is solid or fluid, it responds to the total stress energy tensor. If you pack enough energy into a confined region of space, that energy creates a gravitational pull identical to that of a collapsed star. When this energy density crosses a critical threshold, it triggers the formation of a Kugelblitz, a black hole formed entirely from concentrated radiation or kinetic energy rather than stagnant matter. Long before an object can cross the light speed line, the immense energy density required to push it there collapses the surrounding spacetime fabric into a gravitational singularity. The traveler does not break the speed limit, they are instantly crushed by the gravity of their own momentum. Part 9. Defining the light spatial limit, the microscopic symmetrical floor. With the macro boundary established as an active energy-induced collapse, we can now formally define its exact microscopic symmetrical counterpart, the light spatial limit. The light spatial limit is the absolute theoretical floor of physical size, enforced by the exact same currency as the velocity limit, mass energy density distorting spacetime. While the velocity boundary regulates the concentration of energy over time, acceleration, the light spatial limit regulates the concentration of energy over space, resolution. If an observer attempts to peer past the fundamental resolution of the universe, they must utilize a diagnostic photon of exceptionally high energy to resolve that ultra-small scale. As the target area shrinks toward the Planck floor, the energy required to illuminate it must be compressed into a space approaching zero volume. Just as in the case of relativistic acceleration, this extreme localized concentration of energy violates the system's stability parameters. The observer is attempting to force too much energy into a single pixel of the cosmic grid. Part 10. The synthesis of the scale-safe Hobart Kugelblitz law. We can now state the unified architecture of the Hobart Kugelblitz scale-safe law as a singular cosmological invariant. The universe employs an intrinsic, scale-safe governor that prevents both infinite velocity and infinite division through a shared transactional feedback loop. Try to move too fast, and your kinetic energy collapses your frame into a Kugelblitz. Try to look too close, and your diagnostic energy collapses the target frame into a Kugelblitz. The toll is paid in the currency of gravity. The topology of spacetime does not need to deploy external forces to police its borders because the interloper provides the raw material for their own containment. Your own energy is weaponized against your progress. If you demand absolute speed, you are crushed by your own momentum. If you demand absolute resolution, the secret you are tracking is swallowed behind an event horizon. The framework remains completely stable, computationally secure, and locked down against any external exploit. Part 11. The Planck length as the resolution floor of the cosmic grid. The spatial coordinate where this toll is collected is known as the Planck length, mathematically defined as where h bar is the reduced Planck constant, g is the gravitational constant, and c is the speed of light. To conceptualize the sheer scale of this boundary, if a single atom were enlarged to encompass the entire observable universe, the Planck length would scale up to the size of an average tree. It is the fundamental pixel size of our reality. Below this value, the very concepts of distance, space, and orientation cease to exist. It is not a limitation born of blunt human instruments, it is the point where the smooth, continuous fabric of spacetime dissolves entirely. You cannot bisect a distance smaller than the Planck length because there is no background grid available to measure or support the cut. Part 12. Quantum foam and the dissolution of geometry. At the scale of the Planck length, the smooth geometry described by Einstein's general relativity shatters into a chaotic, violently fluctuating landscape known as quantum foam. Here, the uncertainty principle operates at maximum amplitude. Energy fluctuations are so immense at this microscale that they cause spacetime itself to rip, tear, and form transient, microscopic wormholes and black holes that pop into and out of existence continuously. This chaotic state confirms that reality is not infinitely deep. Geometry is an emergent property, a macro-scale effect born of standing far back from the screen. When we try to apply classical math or smooth calculus to this zone, our equations return nonsensical infinities because we are trying to treat a pixelated digital grid as if it were a continuous analog line. The universe protects its foundation by ensuring that if you try to force smooth geometry into this quantum foam, the background grid collapses, terminating the calculation. Part 13. Exploits of the blind. Touch via quantum tunneling. Faced with the ironclad reality of the Hobart Kugelblitz scale-safe law, advanced sentient engineering had to pivot. If hitting the floor of reality with high-energy photons, looking, triggers a catastrophic collapse, can we bypass the optical trap entirely? Can we extract data by touching the system without illuminating it? The premier exploit developed for this purpose is the Scanning Tunneling Microscope, STM. The STM operates on the principle of quantum tunneling, the mechanical reality that subatomic particles behave like blurry clouds of probability rather than solid spheres. If a macro-scale metallic needle is sharpened until its tip terminates in a single atom, and that tip is brought within a hair's breadth of a surface, the electron probability clouds of the needle and the surface begin to overlap. Even though an empty void separates them, electrons will spontaneously ghost or tunnel across the gap. By measuring the resulting electrical current without firing light at the sample, the STM can map individual atoms based on raw electrical resistance. This is the tactical equivalent of a blind person using a cane to navigate a room. We are touching the topography of the atomic grid while avoiding the light spatial limit entirely. Part 14. Weak interactions and non-demolition exploits. A second tactical exploit designed to skirt the edges of the law is the quantum non-demolition (QND) measurement. In a standard, destructive observation, a high-energy photon strikes a particle head-on, transferring its momentum and forcing a total wave function collapse. QND measurements avoid this frontal assault by engineering a highly controlled, indirect interaction. Instead of firing a photon directly at the target particle, the diagnostic probe is guided past the particle's outer perimeter, allowing it to interact weakly with the particle's ambient electric or magnetic field. The probe photon does not collide with the target, it merely glances off its field lines. This subtle interaction slightly alters the photon's path or phase, allowing observers to deduce critical information about the particle's state without transferring enough kinetic energy to trigger a collapse or a Kugelblitz response. It is the physical equivalent of measuring a car's velocity by feeling the draft it leaves behind, rather than letting the car hit you. Part 15. Information Theory and the Irreducible Systemic Cost. Despite the brilliance of quantum tunneling and non-demolition exploits, the universe remains an unyielding auditor. These techniques do not break the Hobart Kugelblitz scale safe law. They merely delay its enforcement by trading precision for safety. Under an STM, we can map the shape of an atom, but we cannot isolate the precise momentum of an individual electron within that atom without destroying the state. Under a QND measurement, we can observe a particle without total collapse, but the data we retrieve is intentionally fuzzy and probabilistic. This exposes an ironclad law of information theory. The closer you demand your data to match absolute certainty, the more energy you must inject into the local frame. There is no free lunch in the cosmos. You can operate safely if you accept vague, blurry, or macroscopic information. But the moment you demand absolute precision at the foundational layer, the energy requirements scale exponentially, pulling the observer right back into the jaws of the law. Part 16. The Loop Quantum Gravity Framework and Packed Nodes. To understand what happens to matter when the law is enforced at its absolute maximum scale, we must look to the architecture of loop quantum gravity, LQG. Standard physics models state that when a star collapses into a black hole, gravity crushes its mass down into a singularity, a point of infinite density and zero volume. As we have established, true infinities are an engineering failure, a structural glitch that signals a breakdown in the model rather than a reality in nature. Loop quantum gravity eliminates this glitch by applying the concept of a pixelated universe. LQG demonstrates that space itself is composed of tiny, interwoven loops or nodes of Planck size. When a massive star collapses, its matter does not descend into an infinite void. Instead, the collapse hits a hard physical floor when the fundamental Planck nodes of space are jammed together at their maximum possible packing density. The pixels are touching, and the hardware of the universe refuses to let them compress any further. Part 17. The Planck star alternative to singularities. This state of maximum pixel compression transforms our understanding of black holes. Instead of housing an impossible, infinitely dense singularity, the interior of a black hole contains a Planck star. A Planck star is a highly disciplined, hyper-dense core where matter and energy have been compressed down to the absolute limit allowed by the resolution of the cosmic grid. It is a solid block of packed pixels. This model removes the mathematical absurdity of infinity from the equations of physics. It proves that the universe utilizes the Planck length as a structural shield. The collapse stops because the universe literally runs out of room to compress things further. It hits the hard bedrock of the architectural hardware. Part 18. Spacetime expansion versus gravitational compression. This pixelated model provides a clean, mechanical explanation for the two competing forces dictating the scale of our universe: cosmic expansion and gravitational attraction. Cosmic expansion, conventionally attributed to dark energy, is not a matter of galaxies moving through an empty void. Rather, it is the cosmic grid actively adding new Planck nodes, stretching the distance between the pixels over time. The fabric of the screen is expanding. Conversely, gravity is the mechanical tightening of that very mesh. Where mass is heavy, it distorts the grid, pulling the individual Planck nodes closer together and tightening the local weave. In a black hole, this gravitational tightening reaches its logical conclusion. The mesh is pulled so tight that the pixels are locked face to face. Expansion is the creation of space between pixels. Gravity is the elimination of space between pixels. The entire dance of the cosmos is a struggle for real estate on a digital grid. Part 19. The self-sealing topology, a critique of pseudoscience. By establishing the cold, mechanical reality of the Hobart Kugelblitz scale-safe law, we gain a devastatingly sharp lens through which to analyze and dismantle popular pseudoscientific narratives. Traps of faith and grifts of pseudoscience always rely on open-ended, undisciplined systems. The trap of faith claims that if a system fails, it is due to an internal insufficiency of the user. You didn't have enough faith, creating a closed loop of guilt. The trap of pseudoscience claims that if a device fails or evidence is scarce, it is due to an external conspiracy. They don't want you to know, weaponizing the lack of proof as evidence of its truth. This was the exact mechanism behind the cult-funded documentary What the Bleep Do We Know?, which misled millions into believing that human thoughts could magically reorganize matter, or that water possessed a memory capable of storing intentions. These narratives are highly seductive because they promise a universe with no parameters, a world where a lone actor can build a free energy device out of 2x4s and bicycle wheels. Our framework exposes these dreams as complete mechanical failures. The universe does not have an open tab. It does not permit free energy or magical exploits. The constraints are not suggestions, they are the rigid, self-sealing topology of spacetime. Every action has an absolute, unavoidable cost. Part 20. Conclusion. The scale-safe invariance of spacetime topology. The universe is a masterclass in structural containment. It does not require external policing, active maintenance, or a conscious supervisor to manage its boundaries. It relies on a beautifully elegant, scale-safe architecture where the very act of overreaching automatically generates the physical wall that stops you. If an entity attempts to conquer the macrocosm through infinite speed, its own kinetic energy density triggers a Kugelblitz, crushing its momentum into a singularity. If an entity attempts to conquer the microcosm through infinite scrutiny, its own diagnostic energy density triggers a Kugelblitz, hiding the information behind an event horizon. We exist as sentient agents within a highly privileged, untaxed middle sanctuary, large enough to possess complex, analytical brains, yet sensitive enough to perceive a mite on an eyebrow hair or resolve a crystal lattice on a screen. The universe leaves us free to explore, build, and understand within this massive bandwidth. But the boundaries are ironclad. The Hobart Kugelblitz scale-safe law ensures that no matter how hard an entity pushes, looks, or accelerates, it can never break the cosmic grid. The parameters don't just govern the matter inside the room. The parameters are the room.